Okay, lesson 28 is triangle congruence theorem, side angle side. So basically it's just proving triangles congruent by a theorem that we're going to label as SAS, it's side angle side. Okay, so lesson 28.
So you can say one is like triangle SSS?
It's like side, 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 yeah, just like that. Okay, so when we talk about the included angle or the included side,
Oh, my bad, sorry.
when we talk about the included angle or the included side, we talk about two sides that make the angle included. So if I say side DA and side BA, the included angle is angle A. Okay? So for the definition of included angle, it's the angle created by two sides. So if I said BC and DC, the angle that is included is C. Yes, sir? Oh, you're going to say yes. I'm sorry. I'll ask you next time on the hard ones. Okay? So when we talk about identifying included angles, it's just that, the one that is created by the two sides. So here we go. Example 1. What is the included side? Okay, so now we're talking included side of angle A and angle B. Okay, so if I talk angle A and angle B, the side that they have in common is AB. Okay, it's side AB. Now if I'm talking included angle of BC and CD, it's angle C. Anybody confused on that? Do I need to get a little more into my definition? Okay, so example 1, complete then. Alright, so here's the formal definition of the side angle side postulate. Sorry, I said theorem, I meant postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent by side angle side. So here we go. Triangle and its included side, I'm going to make it kind of exaggerated. So if this side, this angle, and this side, these don't necessarily have to be the same, are the same as a different triangle that has similar measurements, where this angle, this side, and this side are, then I can state that the two angles, or the two triangles, are congruent. So draw the triangles, label the first one ABC. I go bottom, top, bottom. And the next one, we'll label it D, E, and F. So if I see this, notice the included angle is here. In that formal definition, it said the included angle. I couldn't say it was this side, and that angle over here. It has to be the included angle. So if I see that, I can state that AB is congruent to DE. So AB, side length, right, is congruent to DE. It's labeled right here, okay? And then I know that AC is congruent to DF. And then finally, I know that angle A is congruent to angle D. So I have three things. I have a side, an angle, and a side. And you read them just as you would see them as they go. So side, angle, side will prove these two triangles congruent. And I will state my congruency by saying triangle. We're going to practice this a little bit. If I say triangle BAC is congruent to triangle, and I need to label the other one the same way that I labeled this one, top, bottom left, bottom right, how am I going to name this one? Oh, sorry, I meant to pick on Nick. Nick wanted one. You wanted a question, right?
No.
Oh, so he changed his mind. All right, back to Calvin. Since we went BAC, what should we name this triangle? EDF, right? I have to follow the same order of the triangles because BA corresponds to ED. Notice BA, ED. And AC corresponds to DF. AC, DF. Okay? They go in that order. If I wanted to write my triangle as triangle CAB, CAB, then I can still say that it's still completely true, but I have to go in the right order. Notice that this one is CAB. I have to follow it FDE. Okay, these are the exact same statements. If I look at B and E, they're in the same spots. Look here, B and E are in the same spots. Here, A and D are in the same spot, A and D. C and F, C and F. They're always going to be in corresponding spots. So when I write my congruency, okay, this is a question that a lot of y'all guys miss, and I don't want you to miss it on the test because it's worth 7 points. When we're writing a congruency statement, we write the triangle is congruent, and then we state each side that is congruent. So I would say AB is congruent to DE, AC is congruent to DF, FE is congruent to CB, angle B is congruent to angle E, angle F is congruent to angle C, angle A is congruent to angle D. That's 6 things, and then the triangle makes 7. Okay? It's a lot of easy points that if you don't write them all down, you're going to miss them. Okay? So make sure that we're working hard on those when you see them in your practice. All right. There's something else that I wanted to point out to you guys, but I forgot. Oh, after I state that the two triangles are congruent, I can say that the rest of the sides, I know that this side is equal to this side is equal to this side, and this angle is equal to this angle. And because I know all those things, I can say that these two triangles are congruent by side angle side. Then after I say that they're congruent, I can say by C, P, C, T, C. Who remembers what that stands for? No one. Congruent parts of
Triangles are congruent.
Oh, so here we go. Corresponding. Sorry, I said congruent, didn't I? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. You're going to use CPC, TC a lot in your proofs. So get used to it. So CPC, TC allows us to say the rest. All right. So that was just a bunch of reminders, really. We're going to start the the examples. Now, we have example 3. We're going to get there. Look at example 2, but we're going to work on example 3. Looking at example 2, those triangles, are they congruent by side angle side? Remembering the definition of side angle side says that a included angle, right? So here's our sides, here's our angle, here's our sides, but there's our angle. So are these the same? No, because this one is not an included angle. Okay, it has to be an included angle. It has to be in between. So on example 2, no, you can't use those because the indicated angles in the second triangle are not, there is not an included angle. All right, on example 3, it gives us a nice little tilted triangle. Okay, it says that this angle is equal, or sorry, it says that this angle is the included angle of these two sides, and this angle is the included angle of those two sides. So let's read the problem. It says find the values of x that make the triangles congruent. Spit it out, Junior. All right, so from here, if they're going to be congruent, what do I know about congruent? That means they are equal, right? So what am I going to do to these two things? If they're equal, what am I going to do to these two things? I'm going to let them be equal to each other, right? If this angle is the same as this angle, then they are equal to each other. So example 3, we simply set the angles equal to each other. And then this just becomes an algebra problem. I need to move my 4x. That goes away. I get 2x. Then I need to move my 27. So I'm going to add 27 to both sides. Those cancel. So I have 2x equaling 34. I divide by 2. 17 is my final answer. So if it asks us to find the value of x, I find the value of x and I just circle it. But if it asks me to find the angle measure, what do I need to do with the value of x now? I need to plug it back in, because in order to find the actual angle measure, I have to plug it in and find it. So it doesn't matter which one you plug it into. I'm going to plug it into this one because I'd rather do addition than subtraction. So 4x plus 7. I'm going to plug in my 17. So it's 4 times 17. Somebody get that for me if you would. What is it? I think it's 68, but I'm not 100% on that. 4 times 17, guys. Thank you. 68 plus 7, then 75 will be my angle measure, and that will be the answer for the angle measure. Okay? Be careful to make sure you read the questions. We do horrible about reading the actual questions. All right, example 4, and I like this example because it gives us a nice picture to look at. Okay? So if you don't like all of this extra stuff in here, just draw what they are asking you to find. Okay? So they give you all of this, but you don't necessarily need all of it, right? So let's look at the question. It says, triangles make an X design on a barn door. Use side angle side postulate to write a 2-column proof, and we'll start a new sheet because I need a new sheet. To start a 2-column proof, and then it gives us a given and what we are trying to prove. So we are trying to prove that triangle ABD, we're trying to prove that triangle ABD is congruent to triangle DCA. Now this is what I mean by, if you think this is confusing, just redraw it with only the things that you need. So there's my picture in the top left. If it seems confusing, let's get rid of the stuff that we don't necessarily need. I'm trying to adjust my light and it's not helping. Okay, there we go. So if it's triangle ABD, here's triangle ABD. Notice it's just this left half, okay? So triangle ABD is really just this right here, right? It's the left, top left side, and it has a right angle in it. I'm just going to label it A, B, and D. And I'm trying to prove it congruent to DCA, right? DCA. So it's the bottom piece extended up and across like that. So DCA, DCA. So now all I've done is drawn the triangles back out. And this is a right angle. So now I have my 2 triangles drawn separately. You can keep them there if you feel comfortable doing that, but I like to see them separate. I can also rotate them or whatever it is that you want to do. But in order to start a proof, I of course need the statements and reasons column. So statements, and then reasons in my other side. First reason is normally always a given, and our given in this case was AB is congruent to DC. Ooh. So since AB, we're looking at AB, is congruent to DC, I'm going to mark that in my picture. Okay? So I took AB and I gave it a little mark, and DC and I gave it a little mark. Okay, is anybody confused as to why I did that? Okay, good. So I'm just annotating it in my picture here. So now I want to look. It says we're going to use side angle side to prove this, so that I know that my final step when I say what I'm proving, which is triangle ABD congruent to triangle DCA, I know that my final step reason is going to be side angle side. I know that because they told me that. It said use side angle side. So if I don't use side angle side, we're probably doing it wrong. Alright, so now I'm just going to fill in everything in between that I hopefully can get this done. So this is step 1. Step 2, now that I know that DC is congruent to AB, I need another side. What angle do you think is going to be the ones that are equal to each other? A and D, right? We know that angle A and D are congruent to each other because why? Because they're 90 degrees. It's marked right there. So in our picture, it tells us that they will be congruent to each other because it marks it right there. So we can either say, we're going to, because the way the picture is, we're going to name the angles BAD and ADC, okay? Instead of just angle A and angle D. So the measure of angle BAD is going to be equal to the measure of angle ADC. And we know that because all right angles are congruent, right? So I would just write in the definition of right angles. Okay, I would just write it in, but it's up to you. If you want to write all right angles are congruent, I will accept that answer, it's fine. Next, I have a side, I have an angle, and I need a what? Another side, right? So if I'm going to use this as my included angle, this has to be my other side, right? This has to be. Over here, I have a side, an angle, and a side. So if I'm going to use side, angle, side, I need to show that this side is congruent to this side. So I know that I need to say that to get to my final step. Why do I know that DA is congruent to DA? Seems like a really silly question. Say it again. Well, I made the little tick marks. I know that I need to prove that. But why is DA congruent to DA? Because it's the same line, right? When I break it up into two pictures, it becomes a little more obvious that the statement is needed. But when I'm looking at it, I go DA and DA. Well, that's the same line. Why would I need to say that that's congruent, right? Remember when I told y'all guys about the reflexive property? I said this is the one that's going to really throw y'all off because you're going to go, why in the world would I need to state that something is congruent to itself? This is that case where you need to state that something is congruent to itself. So AD is congruent to AD, or DA is congruent to DA, however you want to state it. But that's the reflexive property that states that. And this isn't property of equality, it's property of congruence. So POC is the answer there. Now, since I have a side, I have an angle, and I have a side, then my final answer will be that the two triangles are congruent to each other by side, angle, side. Questions?